What's up guys, welcome back to my channel. In today's video, we'll be starting a new topic, which is vectors. I'm sure as Extension 2 students, a lot of students, they would have covered this in Extension 1 course. It's a little bit different, it's just we add another dimension. So in Extension 1, you learn xi plus yj, it's only in 2 dimensions. In Extension 2, you come into 3-dimensional world. So that's our first topic. We're going to be talking about vectors in 3 dimensions today. So we'll start with the first example. It says, if it's given us P and Q, so P is equal to 2, 7, -1. So the third dimension is -1. And then Q is 5, -5, and 3. So another way of writing this is the shorter method. To help us understand A over here, e.g. 1. Another way of writing this, P can be x of I, which is 2 of I, plus 7j minus k, -1 k. So x of y plus y of j plus z of k. Same thing for Q. We have 5i minus 5j plus 3k in this case. Now let's look at the question that's asking. It says A, find the vector PQ. Okay. Second is QP, and then the third is the distance PQ. First thing I will do, PQ. How can we rewrite the vector PQ? Always remember, every time you have something like this, you always write the opposite of that. So PQ, the vector PQ is vector Q minus vector P. If it was AB, it would be vector B minus vector A. That is how you do these sort of questions. So next step, what is vector Q? It's this. I'll rewrite this in this form. We have 5, -5 and 3. Easier to equate, minus P, which is 2, 7, -1. To solve these in vectors, it's basically like collecting like terms in algebra. First step, we minus to separate the x's, the y's, and the z's together. So 5 minus 2 gives me 3. Minus 5 minus 7 gives me -12. 3 minus -1 is just 3 plus 1, which is 4. That is the vector PQ. This is I. We'll do I over here. It says QP, same thing. QP equals to vector P minus Q. This time. Come back over here. P minus Q would be vector P, which is 2, 7, -1. Minus, my bad, 5, -5, and 3 in this case. Next step, 2 minus 5, -3, 7 minus 12, and 1 minus 3 is -4. That is how you do I. Now we do I. We'll line over here. Distance of PQ. How do you find distance? Distance is basically, so distance formula, what is the distance formula? So the distance formula is, so we've got PQ, same thing, D then equals to square root of, we get x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 all squared. That is the distance formula. Now we come back to these two values over here again, or vectors in this case. Q. 5 minus 2, so this is basically 3 squared minus this, plus this squared plus 4. So D then equals to square root of 3 squared plus 12 squared plus 4 squared we then get square root of, on my calculator, 3 squared plus 12 squared plus 4 squared is root 13 is the final answer. So D, so distance is then, no, sorry, not root 13, it's just 13. Distance is 13 units. So that is how you do A for example 1. Now we'll go on to example number 2. Looking at this next example, it says A, show vector AB and CD are parallel. B says find if vector AD and BC are perpendicular. So we'll start with A over here. It says show that if AB and CD are parallel. There's two ways of doing this. First method is using the cross product of vectors AB and CD, and if they equal to 0, you know that the vector is parallel. But I'm sure you don't learn the cross product in the course of HSC Extension 2 Maths. That's more towards when you come to engineering or further mathematical studies. So we'll go with method number 2. Is we'll find what AB is first. So vector AB equals to vector B minus vector A. Vector B in this case is 0, 2, 1 minus A, which is -1, 4, -3. When we minus this, like in the previous example, we go 0 minus 1 is 1. Minus 2 minus 4 is -2. And 1 minus 3 is 4. So that is what we get for vector AB. Let's denote that as vector X in this case. Now we do CD. What is CD? So vector CD equals to vector D minus vector C. Next step, D, we have 0, 8, -7, minus C, which is 3, 2, 5. 0 minus 3, -3. 8 minus 2 is 6, and -7 minus 5 is -12. Looking at this, observing these two vectors, we know a vector is parallel when it's multiplied by a scalar magnitude. So for vector CD, let's denote that as vector Y. So vector Y, we can go -3. If we multiply this by -3, vector X by -3, we get -3, 6, -12. So we know that it's when it's multiplied by a scalar magnitude, we know this is then parallel to this vector X. So we have 1, -2, and 4. There you go. So that is how you do A. Now we'll go on to B. Find if AD and BC are perpendicular. Perpendicular, little different concept, which I'm sure you'll learn further into this topic. It involves the dot product. Dot product is basically, let's just say we have x1, y1, z1 is vector 1, and the other vector is x2, y2, z2. When we take the dot product of two vectors, we go, so we've been given two vectors. Dot product of this would be, so let's just denote this as P, vector P, and this is vector Q. Vector P, vector Q. P dot Q equals to x1 multiplied by x2 plus y1 multiplied by y2 plus z1 multiplied by z2. There you go. That's literally what dot product is. So let's come back to AD and BC. So AD is vector D minus vector A. AD. Correct? Vector D would be this one over here. 0, 8, negative 7 minus A, which is negative 1, 4, negative 3. 0 minus 1 is just 1. 8 minus 4 is 4. Negative 7 plus 3 is negative 4. That is vector AD. Now we go to vector BC. In this case, BC is vector C minus vector B. C is 3, 2, 5 minus B, which is 0, 2, 1. Next step, 3 minus 0 is 3, 2 minus 2 is 0, 5 minus 1 is 4. Now we take dot product of this, which will then give me, we'll denote this as P and this as Q. So P dot Q equals to 1 multiplied by 3 is 3 plus 4 multiplied by 0 is 0. Negative 4 multiplied by 4 is minus 8. So we have 3 minus 8, which gives me negative 5. Therefore, PQ are not perpendicular because the dot product does not equal to 0. If a dot product equals to 0, you know that two vectors are perpendicular. So that is how you do example number 2.